Hello everyone, this is Dr. Maggie Mashaly, and through this presentation I'm going to take you through an orientation for all the graduation projects that I am offering during this semester, spring 2022. So I'm going to walk you through all the themes that we have to offer and details and tools and descriptions for each and every project that you can see on the system. So first, by the time you hear this presentation, I'm assuming you have all attended a short orientation about the details of the bachelor project and how this semester is going to be a very different one than all the semesters that you have spent in the university. Most of what you're going to do this semester is going to be research, not studying and examinations and so on. So research is a bit different, it's more interesting, and as I always believe that research is not an activity that is done individually. So research is always better done in teams where we share ideas, we exchange our opinions, and we correct each other or validate each other's opinion. So it's always best to work in teams when it comes to research. So accordingly, I always divide my projects that I author into main topics, and on each topic you will get to work not alone but in a team. Sometimes the team has colleagues of similar level as you, so you might be working with some of your friends on your bachelor project, and in most of the teams we would also find other co-supervisors or graduate students who are working on the same project doing their master's or PhD. I will explain this when we get to each topic, but let me first introduce to you what are the major umbrellas or the major research topics that we are going to work on this year in my research teams. The first one is one of the biggest research teams that we have, which is the team on cloud security. The second one is Tech on Demand, also a very big research group that I have. Next Generation Network, which is related to all the new advancements in networks. And the fourth category is the Internet of Wearable Medical Things, a new project that we are starting. And I will talk to you about all the details and all the topics covered within each one of these major, let's say, research domains. So starting with the oldest research group that we have, the one on cloud security. Cloud security is a research cluster that we have had at the IET department for years. I have started it long ago, since I was doing even my PhD studies, and throughout the years we have had tens of bachelor projects that have worked successfully in this research cluster, lots of master students as well, and current PhD students working on it. And the topics that we are going to be offering this year are co-supervised by Engineer Ahmed Abdel Khaliq. He is a TA at the Networks Department who is doing his master thesis in the topic of cloud security. So you would be working on these projects under the supervision of both of us. And the three topics that we're offering in the cloud security research group is, number one, malware detection in cloud computing environments using deep learning, and two other topics on general machine learning for cloud security. Let me take you through the details of each and every project among those three. The first project, as we mentioned, is called Malware Detection in Cloud Computing Environments Using Deep Learning. So the idea here is that, of course, by now you should have learned the term cloud computing and what the basics of what is cloud computing. You're probably using it every day when you're listening to songs online, or whenever you're streaming a service, or whenever you're storing your files at any Google Drive or Dropbox or at any cloud based service. So cloud is something that we use every day, and the security of the cloud is becoming a more and more urgent need, and an area that has lots of research going on in order to protect the cloud against several attacks. One of them that we focus on is the malware attacks. What do we mean by malware? If you also have gotten into details, for example, on protecting your device, you know about malwares and viruses and trojans and so on. They are all, let's say, not normal behaviors of your system. So typically the system would be working normally unless it was attacked by a virus or a Trojan or any script that is causing it to run in a deficient way. So our target here is that in cloud environments, because they are a little bit more complicated than the normal environments that we have, we are always exposed to these attacks because also we have millions of users for the cloud. So the number of users is huge. The attacks that they initiate is also huge. And our target here is that we want to protect our system against these malware attacks. So the idea is that we always have the system working normally. So we try to learn what this normal behavior looks like. And then whenever this normal behavior changes, we know that something caused this change, and we do the process of anomaly detection, that whenever we feel that the behavior of the system is operating in a different way than the normal way, we try to detect this. So how do we detect this, or how do we apply this step of anomaly detection? In this project, you're going to apply this using deep learning. We have had this project in the past year. Two of our excellent students worked on it, and they developed a deep learning or a deep neural network model that is used for anomaly detection. However, the work is not finished yet, and it still needs lots of improvement to enhance its accuracy and to make it more able to detect more and more malwares or malware attacks in the cloud. So basically, you're going to be continuing the work from past year to continue working on this deep learning model to develop, to add more features to it and to enhance its accuracy. To work on this project, you would need a little bit of information or background info on Python. So you should be proficient in Python, and all the rest of the requirements, I will equip you with it once the project is allocated to you. And this project is eligible for any IET network students. Now, the second and third projects in this research group of cloud security are titled Machine Learning for Cloud Security, Project 1 and Project 2. What these two projects are going to do are basically the two steps of anomaly detection at first. So we always need to examine the behavior of the cloud to understand if this is an anomaly or not. And then one step later, we always need to understand which type of attack or which type of malware caused this anomaly behavior on the system. So here we don't only want to detect if this is an anomalous behavior or not, but we also want to classify it. So we need to do in these two projects a two-stage or a multi-stage algorithm which performs both the steps of anomaly detection followed by anomaly classification. To do this, we usually refer to techniques in machine learning called the ensemble learning. Ensemble learning is the process of combining two or more or multiple machine learning models in order to perform these two-stage algorithms. So the idea here for these two projects is that we know the target that we want to perform detection and then classification. And to perform this, we are going to test different combinations of machine learning algorithms that combined together will provide us with the highest accuracy to detect anomalies and also classify them to determine their types. Okay, so these two projects, whoever chooses them, are going to be working together. Each one, of course, will be implementing his own code and testing his own technique in machine learning or combining different techniques of machine learning. That's why we offer two projects of these, because we have unlimited combinations. So basically we need to try lots of different techniques together. So that's why we need two persons working on the project. It doesn't mean that they're going to do the same work. They will just be working together closely, but each one of them will be using different technique for these two tasks. Prerequisites is of course Python, and the two projects are open for all network students. Now, moving to the second research cluster, which is Tech on Demand. Tech on Demand is actually composed of 4 projects that I have running this year, which are actual real-life projects that we are developing for real-life problems. Okay, so the 4 projects that are inside this Tech on Demand, we're developing the technology for the problem, and it's based on the demand of external entities. We have 4 projects within this research group of Tech on Demand. The first one is a tool called SPPS, which is a hardware-assisted software tool. Second is the project of the Omnidirectional wheeled conveyor. Third project is smart supply chain using blockchain. And the fourth project is automated quality control for Industry 4.0. Inside each one of these projects, I'm offering several topics. Let me shortly explain them to you. So the first project is called the SPPS. This is a hardware-assisted software tool. Inside this project, we're offering two bachelor topics. This is a project that has been going on for 2 years, and it's also co-supervised by one of our TAs at the Networks Department, MSc Engineer Yassine Samaha. He has been doing his bachelor and his master thesis also inside this tool. This tool is actually a government funded tool, so we have a fund that supports the production of this tool. And the two projects are to develop or to continue the development of the front end and back end of this tool. So the first topic that we have is the development of an AI assisted tool for Industry 4.0 and specifically for the front end development. So what you would be doing for this project, basically we already have preliminary work, lots of preliminary work done on the tool, and we want whoever joins us for this project to continue working on the front end of the tool to add more functionalities, to add more to the interface, and to perform further testing to make sure that all the functionalities that are added in the back end are also reflected in the front end. So basically for this project we need someone who is interested and preferably to have previous knowledge in web development in order to continue the development of this web tool. I cannot say much details on this project because, as I said, it's a government funded project, so it's open to all MET students. However, in order to get to the details, to have the actual code that we have and continue working on it, anyone taking this project would be required to sign a non-disclosure agreement for the idea protection and so on before you are actually handed over the project to continue working on its front end. The second topic offered in this project is someone else who's going to be working at the back end. The back end developer would also continue to add more features to the tool. We still have big plans for more features that we want to add. An overview just on the tool to have an idea what you will be working on. It's something similar to ERP systems or SAP and Oracle and so on. Exact details would be offered to the candidate after signing the non-disclosure agreements. We already have a working backend, and what you will be doing is that you will be adding more and more functionalities to this backend, retrieving the data from the database, also integrating the database and adding more to it, extracting data from APIs. So the requirements for this project would be, of course, to have excellent skills in Python and good knowledge on databases and APIs. And again, the two projects under this SPPS hardware assisted software tool is only open for MET students. The second project in the tech on demand idea is a project called the Omnidirectional wheeled conveyor. And this project is also a project that has been going for 2 years in cooperation with the Industrial Engineering Lab. This project is co-supervised with two of my colleagues, Dr. Iman Azab and Dr. Lamia Shaheta, from the Electronics and Production departments. And this project was, in the beginning, we started manufacturing this actual conveyor that you can see here in the picture. I've also attached a video for this conveyor to see it working actually in real life. So we have manufactured one of these conveyors at the GUC. So we have one homemade conveyor of our own at the Industrial Engineering Lab, and we have been working on developing its operation for 2 years now. And in this third year, we have one missing functionality, or I would say an add-on that we want to add to this conveyor that I will explain in the next two projects. So this add-on that we want to do for the conveyor is to add an integrated package tracking framework for the omnidirectional conveyor belt using two techniques which are either computer vision or machine learning. So the idea is that we, on this omnidirectional wheeled conveyor, we have all the products that are moving, the cells and the wheels that you have seen in the picture. They don't all operate at the same time and they don't all operate at the same speed, so they can actually move any products or any packages that you put on top of it two different directions. They can move one to the right and at the same time move another one to the left, another one simultaneously straight ahead, and so on. So this is how it works. But in order to do this, we need to identify what is the type of package that is currently placed on the conveyor. So when you tell what this package is, then you can take the decisions whether should you route it to the right, to the left, or to straight, or to actually keep it still on the conveyor. So in order to make this conveyor operate in a more efficient way, we want to integrate it with a package tracking framework by adding a camera on top of the conveyor that can see all the whole conveyor and all the packages on it at all times, and is able to actually determine which package is this and what is its exact X and Y coordinates, which cells is it occupying. And accordingly, based on these decisions, we would send it to the logic of the conveyor in order to decide how the conveyor is going to react, or what decision the conveyor is going to take in order to move this package to its right place, or to its right destination. So moving to the details of the projects, Project 1 is going to do this task using computer vision techniques. So what you will be doing if you choose this project is first that you will familiarize yourself with the whole conveyor and camera setup. Then we already have the hardware there, so all you will be doing is that you're going to capture video footage for the different packages moving across the conveyor, and you will apply computer vision techniques in order to be able to identify which package is this, how I can identify the exact X and Y coordinates for this package on the conveyor, so that you can tell which cell it is placed on, and then you signal to the conveyor how to move the cells and wheels in order to take this exact package to its destination. Okay, so it's mostly video processing and then a little bit of control in order to connect or to establish the connection and transfer of data between first the camera and then the back end that you will be developing to analyze the video from the camera, and to the conveyor in order to have the whole control closed loop or the flow of information between the camera and the conveyor, and then take or perform the correct actions on the conveyor. This project is open for MET students because it requires previous knowledge on computer vision, because mainly you are going to be performing this task of computer vision, given that all the control tasks for the conveyor have already been developed in the past years. The second technique or the second project is someone else who's going to be doing also the same task but using machine learning techniques. So in the past year we have had one project offered on this topic of performing machine learning to be able to detect and predict which actions the conveyor should take based on its analysis for which packages are these, or to identifying the packages. However, the model was not or did not resolve to high accuracy, so we still need more and further work to be developed on the footage or the video footage captured from the camera in order to identify the packages and signal this information to the conveyor. So this project is mainly doing the same task but with a different tool. The previous one using computer vision techniques, this one using machine learning techniques. You'd also, both of you or both of students who are going to choose these two projects are going to be working together using different techniques. It doesn't require continuous presence in the lab. You just need to take the video footage and then you can also continue working on this video footage and developing your project from home. This project requires a little bit of Python knowledge, interest in machine learning, and it's open for all network students in IET. Third project that we have in the Tech on Demand group is a project on blockchain and the utilization of blockchain for something called the smart supply chain. This is the project in its second year. Last year we have started this project by interest of P&G. They were actually very interested in the concept of smart supply chain and to integrate the blockchain technologies into it. To give you a general idea on what this project is about, the idea of the project was that we wanted to link the vendors and supplies together, so that, let's say, for example, you are a company that is manufacturing soap, and you are distributing this soap across different supermarkets, and you want to be notified whenever any of these supermarkets sells some of your soap, so that you can send him more of it before he runs out of it. Okay, so typically this doesn't happen in reality because the suppliers or the manufacturers don't have any idea about who is selling what quantities. So the concept here is that we wanted to develop a system that is able to notify or to have an exchange or flow of information between the vendors whenever they sell any product of any type to the supplier of this product, so that he can always get a live update about how much of his products are being sold, so that he can always send more before the market is actually starved. So last year we started developing an IoT system for this idea. We started also implementing the basic blockchain to exchange these messages, because these messages should be sent in a highly secure manner. We don't want any other vendor or suppliers to know or how much the other suppliers are selling. So this data is highly confidential. That's why the exchange between these two entities have to be done with high security. So that's why blockchain comes into action. So the idea here is that we want to build this back end of the message exchanging using blockchain. What you will need to be using for this, the software of Hyperledger. This is the software that you would use in order to build this blockchain to exchange the information. And this project is, I'm offering it for network students, and it's a project that is co-supervised with my colleague, Dr. Nada Sharaf. Another one is also offered under her supervision to an MIT student. So we would be working together to implement and deploy this blockchain solution for the smart supply chain. Fourth project, and the final one in the Tech of Demand group, is a project on automated quality control for Industry 4.0, and it's a digital twinning for the robotic arm. Also, this is the project in its second year. Last year, we had a group of around 12 bachelor students working on this project that were developing a system for automatic quality control that performs automated quality control using a robotic arm and a conveyor belt that is able to fetch several products or specific products that are moving on a conveyor belt and move it or place it at different places to detect which products have high quality so that it can be left, and which products have lower quality so that it can be removed. So this project had lots of ideas that we worked on. First on lots of computer vision, lots of machine learning, and this has already been implemented in the past year. And for this year, we want to add all these deployed functions to the robotic arm so that we can actually move or deploy the robotic arm on the conveyor belt to be actually moving and executing all the concepts that we have developed in the past year. So what we're going to work on, if you choose this project, it's also co-supervised with Dr. Nada Sharaf. This is offered for MIT students, and also there is another topic offered under her supervision. You're going to be working together to continue the task that we have started last year with collection of data set for the different products that we will be working on to determine their quality, continue the preparation for the data set, and develop and deploy the different machine learning techniques to perform the task of automated quality control. You'd also be working a lot on deploying these mechanisms on the robotic arm to get it to actually move and execute all the developed machine learning techniques or the developed control steps or the control actions that you need the arm to take based on the results of the machine learning techniques. For this, you need to be proficient, of course, with Python to work with the machine learning techniques, and you need to have an interest in hardware, because also most of the time we would be working on the actual robotic arm to configure it and let it operate as efficient as possible and as correct as possible. Now, the third research cluster, or the third project that I will be offering projects in for this year, is a very interesting one on the next generation networks. This research cluster is all about networks and the recent advancements in networks, and it's divided into two projects. The first one is self-organizing networks. This is a research cluster that is started by us in cooperation with Dell Technologies. They are also very interested in this concept of the self-organizing networks, and another project on LoRa networks and intelligence at the edge. So under the first project of the self-organizing networks, I have 3 topics offered. The first one is self-organizing networks, characteristics improvements using machine learning. And in this project, what you are going to be doing is first to understand what are self-organizing networks. They are the state of the art in networks. Mainly, until you start with the project, if you're interested in it, just let me give you a short overview. As per the name states, self-organizing networks are networks that are able to self-organize themselves without any intervention or without any configuration or troubleshooting from your side. So the network is able to configure itself, it's able to detect any errors, it's able to solve any errors all by itself. So very smart network, as we can predict, and the target is that we are hoping that in a couple of years all of our networks can adopt this idea of being a self-organized networks that configures itself, heals itself, and troubleshoots itself without any human intervention. How we are going to do this? This is a huge research domain that has lots of open questions still. And the first project is going to be understanding first what is SON and what are the basics of SON, or the self-organizing networks, and their operations. And he's going to work on the improvement of its characteristics using machine learning techniques. So by understanding what is the self-organizing networks, we are going to focus on one of its main characteristics and start developing or start building this characteristic using machine learning techniques. As you might have understood, since we want the network to be able to take its own decisions, so accordingly it needs to be equipped with some sort of an AI-based or machine learning-based techniques that tells it how to actually or to perform or how to take a decision by itself whenever an error happens or whenever it's faced with a new situation, that it needs to decide by itself how it's going to solve this situation. So this project is open to all network students, and what you need or what background that you need on this is only on Python. Anything else or any background knowledge, we are going to equip you with it throughout the project. Second project under the umbrella of SON is the self-optimization and self-healing techniques in the self-organizing networks. In this project, we are going to focus on the 2 characteristics of self-optimization and self-healing, which is the ability of the network to heal itself from any problem that happens and optimize its parameters and its configuration in order to have the highest possible throughput. So we're going to be in this project developing and testing different techniques that allow the network to automatically configure its operation to optimize the performance and to be able to self-heal from any errors without having the network failing or disrupted. So we want to have a continuous smooth operation with the ability of self-optimization and self-healing. So in this project, you will first study about all the techniques that we use for self-optimization and self-healing, then work on specific techniques and try to advance them or to add more functionalities to them to enhance the network's capability to self-optimize and self-heal. Also, for this, you will need to have good Python knowledge, and this project is open to all network students. Third and final project in the self-organizing networks umbrella is also requiring Python and is open for network students and is concerned with leveraging the ORAN architectures through machine learning. ORAN is the open standard for radio access networks and is a standard that is being developed for the concept of the self-organizing networks. So this is one of the standards for the radio access networks. However, it's an open source one. So this is a new idea that is being developed in research in the past years. You are going to first understand the basics and the concepts of this ORAN architecture and add more functionalities to it to allow the network to also operate by the self-organizing network concept using different machine learning techniques to improve this ORAN architecture and improve the capabilities of open radio access networks. Now, the second project in the field of next generation networks is two projects actually under the title of the LoRa networks and the intelligence at the edge. These two projects are in cooperation of my colleague, Dr. Minar Al-Aser. She's also offering similar topics in LoRa, so we are going to have one research group that is working on this topic of LoRa intelligence or intelligence of LoRa networks at the edge. The two topics are entitled LoRa LP1 and machine learning at the edge, and the second one is the performance enhancement of LoRa LP1 using machine learning. In these two topics, you first have to understand and learn about the LoRa technology and why LoRa technology is starting to be one of the most preferred technologies for edge computing due to its capabilities. And after having the required background, you are going to be you will understand why that the network or the LoRa network at the edge have lots of parameters that needs to be optimized and to improve its operation. So we are going to develop machine learning models that are actually able to allow the network to self-optimize these parameters in order to enhance the performance of LoRa at edge networks. For this, these two projects, of course, are open for all network students. And the tools you're going to be using for this project is Python, and sometimes to integrate with an already developed simulator for LoRa networks using the tool Omnet++. Now, the fourth research cluster that I'm offering projects in this year is for a project called Internet of Wearable Medical Things. This project was actually inspired by the pandemic and the effects that the COVID-19 had on us, which we are able to determine whether a person has COVID or not by actually monitoring his symptoms or monitoring his vitals. So this project is concerned with the idea of developing a wearable device, and this wearable device would be measuring all the vitals that are required to actually diagnose if a person is infected with COVID-19 or not. And we already have the hardware for this or the preliminary hardware for this project that is able to measure the vitals for the person. And we're going to this year, because this is also an ongoing project, within this year we are going to develop the number one in project one, the machine learning technique that is going to do the diagnostics to given the vitals to decide whether this person probably has COVID or not, of course with the highest accuracy possible. And in the second project, to perform the interface for this project to be actually able to see the data or to monitor the data and the vitals for the patients, as we will explain shortly. So the first topic, which is called the Internet of Wearable Medical Things for COVID-19 diagnostics using machine learning. In this project, this is offered to network students requiring Python knowledge, and the steps that you will be performing in this project is to actually collect and prepare the data set of different vitals for different personnel to collect a data set and prepare this data set in order to be able to be fed into a machine learning technique. And we are going to develop this machine learning models that actually take the patient's vitals as input and to provide or to produce the diagnosis whether this patient is sick or not. In the second project, which is entitled Internet of Wearable Medical Things for COVID-19, the data analysis and app development. You're going to take this collected data and perform data analysis on it in order to analyze the trends in the data and the correlations between the data. So for example, any patient who has his oxygen level very low, he needs to be hospitalized. Anyone who has correlation to, for example, his blood sugar level and the oxygen level and the heart rate. So we've tried to build or to investigate these correlations in the data. So we perform data analytics on the data set that we have collected, and to, besides this data analytics, to develop an application that the patient can have on his phone, for example, and or a web portal that the caregiver or the doctors can see, so that they can monitor the vitals of their patients to determine whether this patient needs, for example, to be call an ambulance to bring him to the hospital if his vitals are deteriorating, and even for the person to see his vitals so that he can figure out if he needs to seek medical help or medical advice. So we need to build an interface that can display the patient's vitals so that they can be viewed and monitored. The data analysis part would be done through Python, and the application is going to be built on Flutter. So these are the two tools that you're going to be using for this project, and it's offered for MIT students. Flutter can be replaced by any equivalent technology. So it's okay that we build the application as a mobile application or as a web portal. This will be investigated and started during the project after your selection. Now, the third and final project in this research cluster is a project on the utilization of AI and machine learning in the ultrasound imaging for tumor detection. This is not much related to the COVID-19 tool, but this is also a part of the project where we get to conduct first a detailed review on the utilization of machine learning and AI techniques for tumor detection. In this project, or in this idea, people have been having this idea for long that using the different ultrasound imaging for tumors, if you feed them to the right machine learning technique that is hopefully having good accuracy, you can actually determine whether this ultrasound image of a tumor to diagnose it and to tell if this tumor is benign or not. So the idea here is that we also have preliminary work on this project. So first we're going to understand and perform a review on the state-of-the-art methods that are done for this task of tumor detection or tumor diagnosis using machine learning. And you're going to work on the further implementation and testing of different techniques to improve the accuracies that we have reported in the past. This project is open for network students, and as a prerequisite, you need to have good knowledge of Python in order to work on this project. So that was it for all the projects that I am offering this year. Thank you so much for listening, and I'm hoping that if you have any further questions, of course, email me on my email displayed here. And I'm looking forward to seeing those of you who select this project and starting the work together. Thank you, good luck, and see you soon.